Welcome back to the Deep Dive. Today we are grabbing our hard hats, maybe some safety goggles too, because we are drilling straight down into the foundation of Mendix application architecture. We're talking about the domain model.
That's right. It's fundamental.
If you're building low-code apps, or you're learning, that the data structure underneath dictates pretty much everything else.
Early does.
So our mission today, it's simple, really. We want to give you that precise conceptual grounding, kind of the shortcut you need to master this core blueprint. We're going to look at this visual map of the data world, understand the 4 key types, the colors that define it, and figure out how Mendix turns what's essentially a drawing into a real working database.
Yeah, and what's fascinating here, I think, is how Mendix makes this abstract idea of a data structure so tangible, so visual. When you open the domain model in the Studio Pro, you are literally seeing the entire data universe of your application laid out.
It's a blueprint.
Exactly. It's the architectural blueprint. Shows all the existing entities. Think of those as the rooms in your data house and the associations, the hallways connecting those rooms. This visual map is, well, it's absolutely fundamental.
Okay, and scope-wise, let's clarify that right away. Yeah. The domain model is the core for the whole app. But each module, these sort of mini apps within your project, actually has its own specific domain model section, right?
That's correct. Each module defines its own piece of the puzzle.
But crucially, they don't operate in isolation. I like the analogy we found for this. Imagine each module has its own specialized notebook, right, with its data definitions inside. But all those notebooks, they're stored on the same central library shelf.
Nice analogy.
So the data is defined locally, which is great for keeping development tidy, but it's globally accessible across the whole app for integration. Feels like a good balance.
Yeah.
Local organization, shared resources.
And that centralized access, that library shelf, is precisely why understanding this architecture is so vital. It leads us straight into, I think, the most crucial concept early on. The 4 distinct building blocks. The entity types.
Oh, yes.
Get this choice wrong at the beginning, and you're potentially baking in performance issues, maybe even security problems right from the start.
Exactly. That was, for me, one of the biggest takeaways from digging into this, that not all data is treated equally in Mendix. And these 4 types, they're even color-coded in the development environment, which helps communicate their function instantly. So let's break down these 4 pillars based on their color and what they actually do.
Okay, sounds good. Let's start with the absolute foundation. Persistable entities. They're marked blue. This is the data that needs to stick around. It needs to live, well, maybe not forever, but until you explicitly decide to delete it.
Right, permanent stuff.
Exactly. It's stored permanently in a relational database. The analogy, saving a photo to your phone's gallery. It's durable. Things like your customer records, order details, those are almost always blue, persistable entities.
Okay, blue is permanent. Got it. What's next?
Next up, we have the temporary data, non-persistable entities. These are orange. Now, this data only exists while the application or maybe just a specific user session is running. Crucially, it is not saved to the database automatically. Think of it like using a whiteboard during a meeting. You write stuff down, use it, and then you erase it afterwards.
So temporary calculations maybe, or stuff you only need for one screen.
Perfect examples like complex calculations you don't need to store long-term, or maybe product query results that you just need to display right now.
That distinction seems huge for performance. I mean, if you don't need permanence, why clog up the database, right?
Precise.
But hang on. If orange data is only held during a session, what happens if, say, the user session crashes? Or they accidentally hit the back button halfway through filling out a really long form using these orange entities?
Yeah.
Do you just lose all that input?
That's exactly the kind of critical thinking you need here. It's a trade-off. If you do use non-persistable entities to hold temporary user input, you need to build specific logic, often using something called an event handler, to explicitly save that data somewhere safe before the session might terminate unexpectedly. Or you accept the risk of data loss for that temporary state.
Okay, so it forces you to be very deliberate about data volatility right from the design stage. Performance versus risk.
You've got it. It forces that decision up front. Now, the third type is quite interesting. External entities. These are colored purple.
Purple.
With these, the data isn't really yours at all in terms of storage. It lives entirely in another application, maybe a different system or an external service, and your Mendix app consumes it via an API.
Like calling out to get data from somewhere else.
Exactly. The analogy we found works well.
Yeah.
You're borrowing a book from a friend's library. You can read it, you can use the information, but your friend owns the book and manages its storage. You're just accessing it.
Right, okay. So Does relying on these external entities, the purple ones, introduce a potential bottleneck, a latency risk? Like, if our app constantly needs to fetch real-time products data from some, I don't know, slow external inventory system every single time a user looks at a product, haven't we just made our app's speed dependent on how fast that other system is?
Absolutely, that's the trade-off. You exchange managing the storage yourself for dependency on an external source, and yes, potential latency. That's why you typically use external entities when having the absolute real-time authoritative data from that external system is non-negotiable, and you either accept the potential performance hit, or perhaps you build some clever caching mechanisms, often outside the domain model itself, to mitigate it.
Okay, makes sense. Real-time need justifies the purple approach. What's the last color?
The final one, relatively newer, is view entities. These are green.
Green views.
This is derived data. It's not raw data stored directly. Instead, it's data created from the result of a stored query. Specifically, you need to use OQL, that's Mendix's object query language, to define this summarized data set.
Hold on, let me make sure I'm getting that technical bit. OQL, this Mendix query language, is what you use to build these green view entities.
Correct. OQL lets you query the objects within your Mendix application's memory or database. For view entities, you use it to define a specific query that shapes the data you want. It functions like, say, a report card that summarizes remarks from multiple subjects. The report card itself, the view entity, isn't the raw data of every test score, but it's a powerful, calculated summary based on that data.
Okay.
One note for architects listening. Using these currently requires enabling OQLR version 2 in your project settings, and they're sometimes still marked as a beta feature. So there's maybe a slight architectural risk of things changing around them in future Mendix versions. Keep that in mind.
Good flag. Beta means proceed with awareness. Okay, so we have our 4 entity types. Blue for permanent, orange for temporary, purple for external, green for views. Once we've defined the nature of our data with these colors, we obviously need to show how they connect. Let's take our simple example, the blue persistable entities, customer and order. How do we show the relationship?
Right. So beyond just having the boxes, you draw lines between them. These lines are the associations.
And these lines aren't just lines, they carry meaning, specifically about how many of one thing relate to how many of another.
Cardinality, right?
Exactly, cardinality. We'd establish, for instance, that one customer can be linked to many orders. That's a classic one-to-many relationship.
Visually, it might show a one near customer and a for many near order connected by that line.
Precisely. And that line, that defined relationship, dictates how data flows between them and how Mendix handles retrieving related information. The customer's orders, for instance.
But what else is embedded in this diagram? It's not just boxes and lines showing relationships, is it? There's more intelligence baked in. Oh, definitely. That's a great transition because moving beyond just the basic connection, the domain model diagram embeds other crucial structural and, importantly, behavioral elements that help ensure data integrity and consistency. Structurally, you have useful things like annotations. Think of these as digital sticky notes right on the diagram, essential for developer sanity, really explaining the purpose of an entity or maybe a particularly complex relationship.
Good for documentation within the model itself.
Absolutely. And then there's generalization. This is a concept borrowed from object-oriented programming. It's where one entity, let's call it the child, inherits all the attributes and associations from another entity, the parent.
Like a specialized version of something more general.
Exactly. You might have a generic customer parent entity with basic attributes like name and address. Then you could have a corporate customer child entity that inherits those basics, but adds specific attributes like VAT number or industry. It promotes reuse and structure.
Okay, so generalization brings some coding concepts into the data structure. But you mentioned behavioral elements too. That sounds like the model starts doing things, actively protecting itself.
That's a perfect way to put it. These mechanisms define the data's active life, its behavior. Validation rules, for example. These ensure data correctness before it even gets saved. If an attribute, say an email address, must be in a valid format, or perhaps an order quantity must always be greater than 0, the validation rule enforces that. It's like your bank checking your PIN before allowing a withdrawal.
Built-in data quality checks.
Right. Then you have event handlers. This is logic, often a microflow, that gets triggered automatically when specific things happen to a data object, maybe before it's committed, saved, or after it's deleted.
Like an automated reaction.
Yeah, like setting an alarm that only goes off when a certain condition is met for that specific piece of data. Very powerful for automation and side effects. And of course, calculated values. These are attributes whose value isn't stored directly, but is automatically generated based on logic you define, usually involving other attributes. The classic example is a total bill attribute that automatically calculates by multiplying quantity by price.
So the model isn't just static, it has rules and actions.
Yeah.
Now let's zero in on one last element you mentioned, often related to the association lines, the
Yeah.
association owner. This one sometimes trips people up. Why does Mendix care which entity owns the relationship?
The owner. Yes, this is crucial, fundamentally for two main reasons: database storage efficiency and controlling dilution behavior. The owner determines which side of the relationship is technically responsible for maintaining the link in the database, which impacts how foreign keys are managed. But more importantly for behavior, it defines the consequences of deleting an object.
Consequences like what?
Well, in our customer and order example, let's say customer is set as the owner of the association. The association owner settings then let you configure what happens if you delete a customer record. Should all the associated order records for that customer be automatically deleted too? That's a cascade delete. Or should the system just break the link, leaving the orders orphaned, perhaps? The owner setting controls this vital data integrity rule.
Wow. Okay. So it's not just a visual label, it's a critical control valve for data consistency, especially around deletion.
Precisely. It shows the domain model isn't just a picture. It's a detailed configuration of data structure, behavior, and constraints, all defined visually.
Which leads us perfectly into the mechanics. We've designed this beautiful, intelligent blueprint. How does Mendix actually turn this into functional storage when the application is running? What happens behind the scenes?
Yeah, this is where the low-code magic really shines. For those blue persistable entities we talked about, Mendix automatically generates and manages a relational database, very often PostgreSQL, but others are supported too that perfectly mirrors the structure you define visually in the domain model.
So I draw the picture. Mendix builds the database schema.
You got it. You focus on the logical model, Mendix handles the physical implementation. That's a huge productivity boost. And the translation from your drawing to the database is very direct, very efficient. Every persistable entity you define, that becomes a table in the database.
Simple enough. Entity equals table.
Every attribute within that entity, that becomes a column in that corresponding table.
Name, email attributes become name, email columns. Makes
And
it
every single data object, like one specific customer record you create in the app, that becomes a row in the table.
object equals row. Okay, entity table, attribute column, object row. Clear.
So, your customer entity, with name and email attributes, maps directly to a customer table. That table will have columns for name and email, plus, importantly, a unique internal ID column that Mendix manages automatically for every object.
Right, the Mendix ID. How are the relationships, the associations, handled in the database? Are the tables just merged together?
No, merging would be inefficient and lead to data redundancy. Instead, Mendix handles associations cleanly using separate, dedicated association tables. These tables are usually quite simple. They just hold the unique IDs needed to link the related objects. For our order-to-customer link, assuming one customer has many orders, Mendix would likely create an order-customer association table.
And what's in that table?
Just two columns, typically, the order ID and the corresponding customer ID. This setup allows the database to quickly find all orders for a customer or the customer for an order just by joining these IDs without repeating all the customer order details. It's efficient.
Okay, that level of automated structured storage is fantastic. But it does raise a question about security and isolation. If I'm running multiple different Mendix applications, maybe even on the same cloud infrastructure, is it all just one giant shared sprawling database underneath? Can apps accidentally see each other's data?
Good question. And crucially, the answer is no. A core principle of Mendix architecture is application isolation for integrity and security. Each Mendix application you deploy gets its own dedicated, isolated database instance. Even if they're running on similar infrastructure, one application cannot directly peek into, or worse, corrupt the internal data structure of another application's database.
So if my sales app needs some data that lives inside my inventory app, I can't just point the sales app to the inventory app's database table.
Correct. That direct access is blocked for security and stability reasons. If two separate Mendix applications need to share data, they absolutely must use standardized controlled data transfer mechanisms, meaning APIs. We're talking about using web services, specifically things like REST or OData protocols, to request and exchange data in a structured way.
And this is where those purple external entities come back into play, right?
Exactly. The external entities in the consuming app, like sales, act as the secure, defined interface to consume data that is actually owned and served up via an API by the other app, like inventory. It's controlled sharing.
It's like that analogy we touched on earlier. Every Mendix app is its own independent restaurant kitchen.
Mm-hmm.
You can't just wander into another restaurant's kitchen and start grabbing their ingredients, their raw data. That would be chaos and probably unsafe.
Right.
But you can place an order through the waiter, that's the API, and the waiter delivers the finished dish, the requested data, through a secure, controlled process received by your external entities.
That's a perfect summary of the architecture. You have these localized, well-defined data models within each app, ensuring their own integrity through those structural and behavioral elements we discussed. You have isolated storage for security, and you use standardized integration patterns, like APIs and external entities, for any necessary sharing between apps. The domain model isn't just where you define the data, it's really where you define the entire data lifecycle, its structure, behavior, storage, and sharing rules.
So if we connect this all back to the big picture, it makes total sense why the domain model is often called the heart of a Mendix app.
Absolutely.
Because it dictates not just what data you have, but really how it behaves, where it physically lives or doesn't live, and how securely it interacts with the outside world.
Couldn't have said it better.
So, for everyone listening, as you move forward designing your own Mendix applications, really remember those 4 colors, those 4 fundamental states of data ownership and transience. Blue for permanent storage, orange for temporary session data, purple for borrowing external data via APIs, and green for creating derived summary views with OQL.
Getting that choice right up front is key.
Exactly. Which brings us to our final provocative thought for you to mull over. Given these 4 distinct types, and the massive consequences their choice has on performance, security, external dependencies, and even development complexity, how does consciously defining your data type, first deciding if it's blue, orange, purple, or green before you build any UI, any logic fundamentally change how you anticipate and maybe even mitigate the scalability and security challenges you might otherwise only discover much later, perhaps even when the application is already live? That initial architectural decision seems like it could be the real key to unlocking efficient, robust, low-code development. Something to think about.